What's up, everybody? Welcome back. It's a little bit, I'm a little bit excited because everything worked so great that I actually included a few more things in from where we stopped last time, and I will go and just quickly show you everything that we have implemented so far. So together we worked on a little bit of everything except for how to display this plot, but together we worked on how to connect this interface with the MPI-based module that is running behind to compute the experimental variogram of my sampling data set. Then run the genetic algorithm that is also within that MPI-based module to get the best fitted model. And the way it works basically is you take the blue lines, the blue points, and you're trying to guess the best red line that will fit this experimental variogram. So we, I don't think I need to go over how we implemented the mechanism of these objects. So again, it's basically like we have the CPU count, right? The number of CPUs that we have in our machine, and we set a seal that we should not exceed. We do it. The machine is not really functioning the same way we are functioning, but because we know the machine should normally have like maybe three or maybe some, not three, but some of this, right? A little bit of this just to operate the OS. And we decided we will use 80% or less of this number to run anything else, but then the remaining CPUs, we just want it to be for the OS, right? Which is a good idea because you don't want your machine to, work so hard that at some point you will have a frozen laptop. You don't want that, okay? And I guess it's also good because I don't know if we still have that type of issue nowadays, but back in the days, there used to be an issue where if your laptop is overheated, it will just shut down. I think even recent laptop will have that mechanism, but back in the days, the shutting down is not even the worst part of it. The worst part is the melting of some electronic components on your motherboard. So I don't know. I feel like you don't want to get to that point where your laptop is just running too many things at the same time that you have that over heat problem. So yeah. Anyway, so now we have these two options here that I can also explain. You can run the experimental, you can run variogram modeling on the actual random function without normalizing it into z-score or Gaussian scores, or you can normalize it, or you can compute the z-scores of the random function and do variogram modeling on the z-score. So most of the time, when you don't want to fight with multi-scale issues in your data set, you will use this. When you go back to the z-score field, you can do everything you want, and you use the inverse transform to get back to the actual scale of your input data, which is a good idea sometimes. But yeah, I just wanted to include this just so that if someone is also working on something similar, you can think about this. So now, because I have it, what I did is, instead of having just one module where you can switch between the two states, I just implemented a new one. So it's basically the same thing, but when you normalize some of the stuff that you need to normalize, you can also include normalizing the z values, right? The values that you use to run your your uh your simulations. So yeah. Now what else can I do? Okay, I will just explain real quick everything that we have here. If I close this and I load it, and I run it again, you will see it will just show this because I have the files behind. So I have this one to read the parameters, and I have another file where I read, where I'm reading the experimental Variogram. So I have them, right? So now I can just explain. I think it's better if I just explain what we've done so far, like, because at this point I can say this specific application to me looks complete. Now, if you want to take it one step further, you can do it. I can take it one step further. In fact, I might just start making new videos, like a new series of video for how you will do this, but now to establish communication between your local machine and CCR. I will do it. That I will do. And I will share with you again. I like to do these things, like, sharing a little bit of what I can do with you so that you know what you can do, because I do it so you can do it. If I do it, you can do it. Yeah. Ooh, we're running out of time. So let me just go quickly and explain everything that we have here. To make this plot, obviously, you need a function to plot. So, like I said, if you go and Google Q custom plot, this is what you will have there. So they will explain you how to use the class. Very simple, very straightforward, nothing very complicated that you have to do there. And you just have to load the data that you want to plot, the X value and the Y value. Now I use this switch over here just to plot the fitted model, but I don't need it when I want to plot the experimental model. I just need the experimental values, which is what we have here. And so how do I get these, right? You remember we had a function that we run after 6 seconds to check if the parameters are ready. So if we have the parameters, we can read them, put them into the corresponding variables, and we can use those now to populate a string over here. That string is what you use next to display the parameters. So this line over here is just to display the parameters on the text edit, okay? Nothing else, but just using it. So you grab the parameters and you display them, and so now you can plot the experimental variogram. You can plot the adjusted variogram, that is just, taking these parameters, and depending on what type you have, where to connect your code. So your code will come over here and check model type. If it's 0, it means it's a spherical model. So to connect the program to this part of the code and run it and get the corresponding values so that you can plot them here. That is what you have to do for the red and blue curves. Now what else? The switch. Oh yeah, the way you implement that mechanism, very simple. Again, it's over here. So when I click on that button, what I do is I check if row values ready button is checked. I verify if row values ready button is checked, which means I will be here, and if I click on this, row value is checked. If I click on this, normalized is checked. So it's checked. So depending on the one that I selected, I will have a specific part of the code to run. I mean, the laptop will have a specific part of the code to run. So that's what is happening there. So now I can close this and just open it again so that you see how it works. And run it. Because I feel like if I have to do it all the time, so remember this one is just to set the number of things that we want to use. Because I already have those parameters, it will appear now. I don't even need to specify anything here. But I will run and I will stop, because when I will run it, it will take some time before giving the output. So if I go back to the folder where I have the output, so if I go and I delete this and also this, and I come back and run the script, the program, now it will wait for me to provide some information before starting, and I can put 9 here. Yes, now we don't have anything. So if I use raw values and I click on run, it will start the MPI-based module behind, and it's running now. That's, yeah, and that's the reason why you see this. Now it's running, and I will have to wait until it's done. When it's done, because the code has this function that is after 6 seconds checking if the bin file is ready, it will automatically go check. You will have the bin file, it will read that bin file and display the experimental variogram and the fitted model. So that's how it works. We can take it to a higher step, like a higher level, and do more complex stuff, but I think this is where I will stop for now with this, and hopefully this has been helpful. Hopefully this will help you also do some similar programs or modules. So if you have any question, please feel free to reach out. I love this type of activities. And like I said, I now think about how to do this for communication between your laptop and like a computing server like CCR. So see you next time.